You ever wonder what makes one AI brilliant and another, well, a total disaster? What's the secret sauce that separates a reliable system from one that makes dangerous mistakes? Hint, it's not the code. It's actually a secret recipe. So today we're going to open up that cookbook and see exactly what it takes. All right, so let's get right to it. What's the single most important ingredient in the entire world of AI? I mean, what's the one thing you absolutely positively cannot mess up if you want it to work? It's not the code, and it's not the fancy algorithms. It's the data. That's it. You can have the smartest code in the world, but without good data, it's totally useless. See, an AI is only ever as good as the data it's trained on. And therein lies the problem, a really big problem with where that data comes from. And that problem is what we call raw data. This is the stuff that gets scraped from the internet, collected from sensors, you name it. And honestly, it's a total mess. We're talking blurry pictures, things labeled completely wrong, just garbage. The source material for this explainer puts it perfectly. It's like trying to make a cake using flour that's mixed with rocks and dust. You just can't do it. So how do you get the rocks out of the flour? Well, there's this really clever four-stage process. And what's so cool about it is this fundamental trade-off. As we go through the stages, just watch what happens. The amount of data we have goes way, way down, but the quality of that data just skyrockets. Let's walk through this whole recipe. Okay, step one. This is where it all begins, with the raw ingredients, our huge, messy pile of data. So to make this real, let's say we're building an AI that needs to identify cats. We start by scraping 100,000 images from the web. Sounds like a lot, right? But here's the kicker. The source material says that up to half of that could be pure junk. Pictures of dogs, blurry photos, images that aren't even cats at all. It's a total disaster waiting to happen if we use it like this. So what's the first thing we do to clean up this mess? That brings us to step two, which is basically sifting the flour. And how does that work? Well, it's pretty smart. We use a bunch of different clustering algorithms. Now, just think of these as digital sieves, each one with a slightly different pattern. We run our images through all of them. The only ones we keep are the images that every single sieve agrees is a cat. If there's any disagreement at all, it's out. And this first step is absolutely brutal. Look at these numbers. We go from 100,000 images all the way down to 30,000. We've just tossed out over 2/3 of our data. But the data that's left, so much cleaner. Okay, so our flour is sifted, but is it actually good enough to bake with? That brings us to step three, the test bake. What we do here is take those 30,000 images and we show them to a bunch of different pre-existing AI models. Think of these AI models as like different ovens. We're looking for the images that bake perfectly in every single oven. So if one AI gets confused by an image, even if the others get it right, that image is just too ambiguous. It's gone. And this step is just as tough as the last one. It cuts our data set in half again. We go from 30,000 down to 15,000. What we're left with are only the most AI-friendly examples, the clearest, most obvious pictures of cats that pretty much any AI can recognize. The quality now is getting really, really good. All right, we're at the final and maybe the most important step. This is where the machines meet the humans. Stage 4, the expert taste test. So now actual human experts, for our cat example, maybe it's a biologist or a veterinarian, they sit down and look through all 15,000 of those images. And the rule here is incredibly strict. An image only survives if both the human expert and the AI models agree that it's a perfect, unambiguous example. It's the ultimate final check. So let's just zoom out for a second and look at the whole journey. This chart says it all, really. We started over on the left with a huge amount of low-quality, messy data. And by following this recipe, we've ended up on the right with a tiny, tiny amount of incredibly high-quality, golden data. And what's the final count? From our original 100,000 images, we're left with just 5,000. That's it. This is what's known as the golden seed dataset. It's small, sure, but it is nearly perfect. We're talking an error rate that's practically zero. This is the foundation you can build a reliable AI on. And this whole thing really just hammers home one of the core truths of AI. This quote says it all. An AI model is only as good as the data it's trained on. So you might be thinking, why go through all this work? Why does having this tiny, perfect dataset matter so much? Well, it matters because that perfect seed is how you grow an AI that you can actually trust. And believe me, this isn't just some abstract idea. It has huge consequences in the real world.
I mean, just look at the difference here. You train an AI on that messy, raw junk, you get a model that's unreliable, biased, and frankly, can be dangerous. But if you train it on that golden data first, you build a foundation of reliability and safety right from the start. The AI learns the right way the first time. And in some fields, this is non-negotiable. We're talking about self-driving cars that need to tell the difference between a person and a pothole. We're talking about AIs that help doctors spot cancer on an X-ray, or systems that prevent fraud. In these cases, good enough data just isn't good enough. You need the best, because a mistake could be catastrophic.
You know, it really makes you rethink that old cliche, data is the new oil. Because after seeing all this, it feels more like raw data is the crude oil, thick, messy, and full of junk. But this refined, golden data, that's not just oil. That's the rocket fuel that's going to power the next wave of AI that we can actually trust.